We are going to take our last bit of notes for this chapter. It's called the equal values method. And so what we're doing is we're trying to figure out when the two lines cross. So we had done this before. We did it by graphing and looking at the table, right? We see where two lines cross. And so let's try this one. We're going to see where does this line, y equals 5x minus 3, equal y equals 3x plus 5. And so the equal values method basically says that we want to know where the y values are equal. We want an x value that makes the y values the same. And so basically, if these are both equal to y, then they have to be equal to each other. And so the equal values method is simply a matter of setting the two values for y equal to each other. And now this is a review of solving equations, right? X's are on both sides, and so we're going to move x to the left. So I get 2x minus 3 equals 5 because the x's are gone there. And then I will add 3 to both sides. Get 2x equals 8. And I divide both sides by 2. And I get x equals 4. And the important thing to remember is you're not done when you find x. Remember, these problems are about finding where lines cross. So you always need to give an x and a y. And so what I do now is I take the x that I just figured out and I plug it back into one of the equations. So I do 5 times 4 minus 3, which is 20 minus 3, which is 17. And so it looks like the answer is 4, 17. And I can double check that I'm on the right track by plugging 4 into the other equation. Just make sure I get 17 again. So 3 times 4 is 12. 12 plus 5 is 17. So it seems to be checking out. So 4, 17 is the intersection. And let's just double check on the graph. So I'm just going to have the computer graph this for me. Let's see, so desmos.com/calculator. I'm just going to graph those two equations. Remember, this is all about finding where two graphs intersect. And so I have y equals 5x minus 3. There's the first line. Y-intercept of -3, up 5 over 1, up 5 over 1, and so on. And then y equals 3x plus 5, and so there's plus 5. I don't see any intersection here, but they seem to be getting closer up here, so I just drag up, and sure enough, the red line sort of catches up. And where do they cross? Right at 4, 17, which is the same thing we had predicted. So that looks good. So equal values method, we're solving an equation, setting the two equations equal to each other, figuring out x, then plugging x back in to figure out y. And that's it for notes for the chapter.